Hello dear students, today I welcome you all to the next video that is related to some problems on ellipse. So let us start with the first problem. The first problem states that one more thing, that these problems are of mains level, so they are not going to be very difficult or long like that. So the first question is, let E with the ellipse x square upon 9 plus y square upon 4 is equal to 1, and C with the circle x square plus y square is equal to 9, and let P and Q with the points are given. Then it is asking that whether these points are inside the ellipse, outside the circle. There are few permutations and combinations. Okay, so the basic concept I think that you all might be knowing. It is the one of the easiest questions, that if a curve, for example if a circle is there, like here it is given x square plus y square is equal to 9, and if you want to check that whether this point lies inside or not, then just we will put the value 1 square plus 2 square and minus 9, and we will see that whether if it is less than 0, it is less than 0, that means the point lies inside the circle. Okay, the same holds true for every curve. If the if this is greater than 0, then the point lies outside the curve, and if it is equal to 0, then the point lies on the curve. So I think that you all might be well aware of these properties. So we just checked it by putting the values, and we found that for both the values it is less than 0 for circle. That means both the point P and Q lies inside the circle. And after that I checked both the points for ellipse. Then for one it is greater than 0, and for one it is less than 0. So accordingly selecting the option, it comes. Okay, it was one of the easiest question. Let us move forward. The next question is I think it would be visible if E1 and E2 are the eccentricities of ellipse and hyperbola. Okay, I haven't taught hyperbola yet, but there is nothing so much related to hyperbola here. Actually we are just using the formula to find the eccentricity. Like in the case of ellipse, it is 1 minus b square upon a square. This is b and this is a, and so similarly here it is 1 plus b square upon a square. This is only the difference. So it is saying that if E1 and E2 are the eccentricities of ellipse and hyperbola, and E1 comma E2 is a point on the ellipse given, then k is equal to, it is simply that it is checking whether you know or not the formula of calculating the eccentricities of ellipse and hyperbola. So once you put the formula for calculating of ellipse, the eccentricity, you will get root 7 by 3, and just the formula is same, only in place of minus it is plus for the hyperbola. So square root 1 plus 4 upon 9, that is equal to root 13 by 3. It is for hyperbola and it is for ellipse. I have already written the solutions because it used to take a lot of time, and I didn't find a reason that why in such easier questions I should write and all. In the tough questions it becomes that I need to explain each and every step. So E1 and E2 we have found. This is the eccentricity of ellipse and this is the eccentricity of hyperbola. And since E1 and E2 lies on the ellipse, so just we will put the points and we will find the value of k, that it gives 16, right? Now coming to the next question. This question states that let a line y is equal to mx and ellipse intersect at a point P in the first quadrant. That means a line y is equal to mx and an ellipse are intersecting in the first quadrant. By the first quadrant we mean that both x and y should be positive. If the normal to the ellipse at P, that means the point at which the line and the ellipse is intersecting, we are drawing a normal there. It meets the coordinate axis as these 2 points, then what is the value of beta? This question was asked in mains 2020, and even the last question that we solved, it was also the question of mains 2020, and the first question was from very earlier JEE question it was. So how we will solve it? There are many ways to approach this problem, but the easiest way is to let P x1 y1 with a point, the point of intersection of line and the ellipse, and equation of ellipse is like this: 3 divided by 2 This is the equation of normal. We know that equation of normal to an ellipse x square upon a square plus y square upon b square is equal to 1 at point x1 y1 is given by x minus x1 upon a square and y minus y1 upon b square. This we have derived. If you would be remembering, then we had derived in the class. Now accordingly, if I try to get the equation of normal, I will get this. Okay, this is the equation of my normal, right? Actually I had highlighted this, but after simplification you will get this thing. Okay, this is much easier to handle. Now what it is given that this normal passes through this particular coordinate. So what we will do, just in place of x we will put minus 1 by 3 root 2 and in place of y is equal to 0. See, one very trivial error that many students commit mistake, that they are confused that where we should put the value in place of x1 or y1. Actually x1 y1 we have earlier assumed that it is the point P at which the tangent is intersecting with the line. So you shouldn't put this value in place of x1 y1. Okay, now if we put the value, then we get the value of x1, right? We get the value of x1. Okay, now when I got the value of x1 here, then what we need to do, I need to, since this x1 y1 lies at ellipse, okay, so if I will put this x1 in the equation of ellipse, if I will put, then I can easily find y1. Okay, so here I had calculated the y, and the y comes as 2 root 2 upon 3. The y comes upon as 2 root 2 by 3. Now once we calculate the y, once we get the value of y, then nothing more remains. It is given that this 0 comma beta also lies on this normal. So we will put the value in place of x, we will put 0, and in place of y we will put beta. Then we will get beta in terms of y1, and y1 we have already calculated. So this is the value of beta. So I think that these three questions you would have been able to understand it. So if you are facing any difficulty still, then please do ask in the comment section. Okay, thank you.